We are going to find the missing trigonometric ratio based on the relations. Look at this example. Given that sine alpha equals 2 over 5 and that alpha is obtuse, find the exact value of cosine alpha. As you can see in the book, they used the method of the right angled triangle. We will also do this method and see the alternative method as well by using trigonometrical identities. First, you must pay attention to the nature of the angle. The angle is obtuse, so it is between 90 and 180 degrees. Let's start. So alpha is between 90 and 180 degrees. This will be angle alpha. Now, if we want to create a relation with the acute angle, we can say that it is here angle phi. Now, what is the relation between them? Alpha as an angle is 180 degrees minus this part, which represents the phi. So alpha equals 180 minus phi. Remember that we are working in the second quadrant, so only the sign is positive. So sine alpha is the same as sine phi. Cosine alpha for this obtuse angle equals minus cosine phi. We will not comment on the tan because we only need the cosine. Remember, we have the sine which is opposite over hypotenuse, so we will represent it on the right triangle, while knowing that angle phi is acute. This is the right angle triangle, and here we have angle phi. We know that sine alpha is the same as sine phi. So, sine alpha equals sine phi, which equals 2 over 5. That means opposite over the hypotenuse. The opposite is here. It is 2 and the hypotenuse is 5. And this is the missing side, which is x. Now we will use the Pythagoras theorem, which is hypotenuse squared, so 5 squared equals x squared plus 2 squared. So 25 equals x squared plus 4. X squared equals 25 minus 4, which is equal to 21. So x is the positive square root of 21. Cosine phi is adjacent over the hypotenuse, which is x over 5. We know that x is the square root of 21. So, square root 21 over 5. This is cosine angle phi, which is acute. Remember that we want cosine alpha. Look at the relation we obtained from the quadrants. Cosine alpha equals minus cosine phi. So it is minus square root of 21 over 5. In this way, we calculated the trigonometric ratio by using the right angled triangle. Now for the second method, we know that cosine will be negative for this value because it is in the second quadrant. So, we have the sine and we need to find the cosine. We start with the trigonometrical identity. So, sine squared alpha plus cosine squared alpha equals 1. Sine squared alpha is 2 over 5 raised to the power 2 plus cosine squared alpha equals 1. Now we distribute the power. 4 over 25 plus cosine squared alpha equals 1. Therefore, cosine squared alpha is 1 minus 4 over 25. So 25 minus 4 over 25, the value is 21 over 25. Therefore, cosine alpha is either positive square root of 21 over 25 or negative square root of 21 over 25. But alpha is obtuse. That means we are working in the second quadrant where cosine alpha is supposed to be negative. So, this answer here is the accepted answer. However, this one is rejected. The final answer is minus square root of 21 over 5. In this method, we use the trigonometrical identities. Now look at the book. When it says exact, we do not use the calculator. First, we have the explanation on how to use the right angle triangle. Then we have the explanation for the second method, which is by using the trigonometrical identities. As alpha is obtuse, then cosine alpha is negative. If the question doesn't specify which method to use, then you are free to choose either one, the right angle triangle or the trigonometrical identities. Now, look at these exercises. Try to solve from 6 to 9. In each one, we have given one trigonometric ratio in the nature of the angle, and we need to calculate the other trigonometrical ratios.